Good day, grade 8. I'm Miss Babo, and today's lesson will be about chemical reactions. During this section, we are going to look at what a chemical reaction is, how a chemical reaction occurs, and how we will be able to identify if a chemical reaction has taken place. Firstly, let's start with a definition of what a chemical reaction is. A chemical reaction is a process that transforms a set of chemical substances into a new product. If we have a look at the diagram here, during a chemical reaction, the elements will react with each other to form new substances with new properties. So let's have a look at how to write chemical equations. On our left-hand side, we will always have the reactants that will react with one another to form a product. The product will be a compound. Now, a reminder on what a compound is: it is a molecule made up of two or more different elements that have chemically bonded together. When the reactants on the left-hand side react with one another, it will then form a new product in the form of a compound. So let's have a look at an example of writing a chemical equation using water as our example. The top equation represented is a chemical equation, and the bottom equation represented is a diagram equation. So if we have a look at our top one, which is our chemical equation, we have the reactants, which is H and O, so hydrogen and oxygen, and it gives us the product of water. Now, what's important to remember with chemical equations is the use of the arrow. As a chemical equation, we do not use an equal sign, but we use an arrow instead to show the progression that's made when the chemical reactants react with one another to give us the product. Now, when we speak about the bonds of a chemical reaction, the definition of what a bond is, it is the force which holds the atoms together. During a chemical reaction, the bonds between the atoms will break so that the atoms can rearrange to form new bonds to give us the product, which will be on the right-hand side. So the bonds between the reactants, which is the elements or the atoms between the elements, will break. That shows us that energy is added. We needed to pull or move those atoms apart so they could rearrange to form new bonds, which will form the new product. That means that energy is released. So the rearranging of the bonds of the reactants will give us the product. So let's have a look at the difference between reactants and products. Firstly, what's always important to remember is that the reactants will always appear on the left side of the chemical equation, so the left side of our arrow, and the products will always appear on the right side of the chemical equation, which is the right side of the arrow. With regards to the reactants, they are represented as the elements that are reacting with one another, and they are what's represented before the chemical reaction takes place. The products will be the compounds that are formed after the reaction takes place, and it shows what occurs after a chemical reaction. So let's have a look now at the reaction to form water. On this page, we have the chemical equation, the word equation, and the diagram equation. Let's start with the chemical equation. Our chemical equation is H2 plus O2, which are our reactants, and that gives us water. Now, a quick reminder, what do these 2's represent? The 2's of our reactant side represent that these reactants are diatomic molecules. Diatomic molecules naturally occur as two atoms in their gaseous phase. If we move to the word equation, our word equation is hydrogen plus oxygen, and the product will give us water. The diagram equation shows us the particles or the atoms that react with one another to form the product of water. If we have a look at the reaction to form carbon dioxide, again we have a chemical equation, a word equation, and a diagram equation. If we start with our chemical equation, we have C plus O2 gives us CO2. Now again, what does the 2 represent? It is a diatomic molecule, which means it naturally occurs as two atoms in gaseous phase. If we have a look at the word equation, we have carbon plus oxygen, and it will give us carbon dioxide. Again, the diagram equation shows us how the atoms will rearrange and bond with one another when the chemical reaction takes place to form the compound. Now, how are we able to identify if a reaction has taken place? There are certain things you can look out for to see if a chemical reaction has indeed taken place. The first will be bubbles. It is usually represented as a gas that is released, and you will be able to see the bubbles that are released, especially if it is in a solution. There could also be a color change that occurs, which indicates that a reaction has taken place between the reactants, or there could be a change of state of matter, which indicates that a reaction has taken place. Another way which we can identify if a reaction has taken place is by the sound of a popping sound or an explosion that has taken place. That also indicates that a reaction took place, or the reaction could be smelt, or heat would be produced, which indicates that there has been a chemical change between the elements. Now, a daily observation of a chemical reaction is the process of fermentation. Fermentation is a chemical reaction process where yeast and bacteria release energy and alcohol from sugar. An example on where we can see fermentation is in our bread making process or in the manufacturing of beer and wine. So if we have a look at the equation for fermentation, we have glucose plus yeast gives us ethanol and carbon dioxide. This means that glucose and yeast will react with one another as they are the reactants, and the product will be ethanol and carbon dioxide. Glucose is a form of sugar which will react with yeast, which is a microorganism from kingdom fungi, and the reaction will give us carbon dioxide in a gaseous form and alcohol in the form of ethanol. Thank you for attending my lesson in grade 8. We'll see you next time for static electricity.